Hello everyone, I'm Paul and today we're solving problem 2081, sum of k-mirror numbers. This is hard and the logic for this one is tricky, so here I will show you my thought process and how to solve this. We're given two integers here, k and n, and we need to return the sum of the first and smallest k-mirror numbers. Now, a k-mirror number is a number that reads the same both forward and backward in base 10 as well as in base k. This is why we are given k. Now, in case you know, things that read the same both forward and backward are palindromes. So we need to find numbers that are palindromes in base 10 as well as in base k, in this case in base 2. And more specifically, we need to find the first 5 numbers which meet these requirements, and we need to return the sum of these first 5 numbers. For example, 1 in base 10 is a palindrome, and in base 2 is also a palindrome, so we add these to the result. And these are all palindromes, and these are also all palindromes. So for example, 9 is a palindrome, and this is a palindrome. This reads the same both forward and backward. So for the result, we add all of these numbers in base 10 and we get 25, and this is what we need to return. Now you might think about iterating every number from 1 up to infinity and checking if which numbers meet these requirements and then adding all of those representations in base 10 to the result, but the problem is that will throw a TLE, time limit exceeded. So we need to think about something more efficient. And our strategy here will be the following. We will only care about the first part of the base 10 numbers. So let's say this is a base 10 number, and we will only care about the first part of this number. So let's say we're iterating numbers, every number from 1 up to infinity, just for this first part. And let's say right now we are at number 10. From this number we will build 2 palindromes. One palindrome that has an even length and one palindrome that has an odd length. For the odd length, we will remove the last digit in this number, so we only have a 1. We add a 1 here, and now we will add this in reverse order, so we add 0, 1 here. And for the even length palindrome, we will take this, so we add a 10 here, and we will add this in reverse order, so we add 0, 1 in this case. So this has an odd length, the length is 3, and this has an even length is 4. And then we will take each of these and check if the base 2 representation of each of these is also a palindrome or not. And if we take this, for example, and the base k representation of this is also a palindrome, we add this to the result. Similarly, when we take this and we get the base k representation of this, if that representation is a palindrome, we add this base 10 representation to the result. So as you can see, we will only iterate numbers for this first half of every palindrome, and that reduces a lot of time complexity. Now we have one more problem here, and it's that we need to return the n smallest k-mirror numbers. This means that we do care about the order. Remember, for example, if we have a 10, we can build 101 and 1001. Now the odd length will always have less digits than the even length. So we'll first focus on the odd length and then we'll focus on the even length. So our overall strategy will be the following. We'll start from number 1 and we will iterate every number with this amount of digits. So first we are iterating every number from 1 up to 9. And every time we only care about the add length palindromes. So from 1 we can build a 1. We don't care about even length palindromes, we only care about this. This in base 2 is also a 1. This is a palindrome, this is a palindrome, so we add the base 10 representation to the result. Remember, we need to build everything in sorted order because we need to return the n smallest k-mirror numbers. So let's say we have a 1, and from this we can build a 1 or 11. If we take this 11, this is fine, this is valid, but first we need to take many other numbers. So we can't just take this at first, because we need to return the n smallest k-mirror numbers. This is why we'll only focus on the add part first, and once we iterate every digit from 1 to 9, we will focus on every digit from 1 to 9 again, but with the even part. And once we end all of this from 1 to 9, we will add a 0 here, and we will repeat the same process. So now we are iterating every number with 2 digits, meaning numbers from 10 to 99. And first we will focus in palindromes with add length, and then we'll focus in palindromes with even length. So from 10 we can build 101 and 1001. First we'll forget about this and we will take this. We know this is a palindrome, and then we transform this into base k and we check if that is also a palindrome, and if it is, we add this to the result. For example, next we have 11, and we can build an add length palindrome with this, which will be 111, and the even length palindrome will be 1111. So for now we only care about this. We know this is a palindrome, and we need to check if the base k representation of this is also a palindrome, and if it is, we add this to the result. And we'll continue doing the same up to 99, and then we will come back to 10 and we will repeat the same process, but only with the even part. So we can build a even length palindrome for this from this, which will be 1001. And we know this is a palindrome. We check if the base k representation of this is a palindrome, and if it is, we add this to the result. Next we do the same with 11, 12, 14, and so on up to 99. And once we finish with these 2 digits, we start with 3 digits, meaning with 100. And we'll check every number from 100 up to 999, first with the add length palindromes, then with the even length palindromes. And this is how we can build our list of valid base 10 numbers in order, because remember, we need to do this in order. This is why this is hard. So now let's go with the code, and hopefully you will get the idea. First we'll create a function which will take a base 10 number, we'll transform this number into a base k number, and we'll check if the new base k number is a palindrome or not. So we'll call this base k is pal, and this takes a base 10 number. We will store this base k number into an array, and now while we have a number, base k dot append number modulo k. This is what we do to get every value for every position in the base k number. We get the value for each position, and which is this, and we add that to the array. And now we need to reduce the number, so num divided equal k. And finally we will return base k equals base k in reverse. Okay, so we are checking if the final base k number equals base k in reverse. Now the result is an empty array, and finally we will return the sum of this result. And here in between, the left bound will be 1. Remember, we are starting from 1, and while the length of the result is more than n, the right bound will be left times 10. Remember, first we are iterating every number with 1 digit, then we are iterating every number with 2 digits, then with 3, and so on. Next, for every parity in 1, 0, we'll take 0 as even and 1 as odd. Remember, we need to start with odd. That's how we get first the palindromes with the smaller length, which is what we need, because we need to store every selected number in order. So we start with odd, then we continue with even. And now for I in range from left to right, if the length of the result is equal to n, we break the loop, and now we need to build the palindrome. And there are basically two ways to do this. We can do this with math or without math. Here I won't use math. I will do this with strings because I think it's more intuitive, but you can do this with math if you want. We'll call our palindrome copy. This is initially I in string format. And now if the parity is even, meaning if it's 0, our copy will be copy plus copy in reverse. We reverse a string like this in Python. Else copy equals copy, and here we'll take a substring from 0 up to -1. We are removing 1 digit from the copy, and here we need to add copy in reverse like this. Finally, we transform copy into an integer like this, and now we have our palindrome, and we need to check if the base k of this palindrome is also a palindrome. So if base k is pal, and this will take copy as an argument, and if this is true, we add to the result copy. And finally we need to update left. So now we were iterating numbers with 1 digit, and we now say left equals right, and now we are iterating numbers with 2 digits, and then with 3, and so on. So first we focus on odd length palindromes, and we iterate every number from left to right, and we build the corresponding palindrome, and we check if that in base k is also a palindrome, and if so, we add that to our result. We repeat the same process for every number in between left and right. Then we move to the even palindromes, and then we update left. We continue, we keep adding digits until the length of the result is n, and then we break the loop, and we return the sum of the selected values, meaning the sum of the result array. So this is it for the code. Now let's submit this and see if it works. This is a lowercase I, so let's fix this and try again. As you can see, this works and it's very efficient. Time complexity for this will be roughly big O of n times log m. This is roughly log m where m is the palindrome, this num here. And space complexity will be roughly big O of n. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.